Alright, so right now we're creeping towards midnight and I'm getting tired, so I'm going to try and cover as much of the difference quotient as possible. But I am lacking sleep, so bear with me. So for starters, we have the difference quotient formula, which you will not have to remember. It will be given, most likely. If Lydia is watching this, my friend, it will definitely be given. Anyone else, it will probably be given because it's kind of cruel and unusual not to give this formula. It is complicated and useless outside of math, so I hope they give it to you. So here it is. We're going to use this as a template for all of our examples. So the first example I want to start with is the following. So here I'm going to write out our equation, and it's going to be x squared equals 4x plus 7. And so that's our equation. We'll have to, let's see, do we have to get that on one side? Or just, well, it didn't do that here. I guess we can just keep rolling. So what we need to do first is find f of x plus h. Before doing this, before worrying about this, let's worry just about this part here. So for f of x plus h, you just have to plug in x plus h into all of the x's that you see here. So yeah, let's just set all this equal to 0. So x squared minus 4x minus 7 equals 0. Yeah, that feels right. So now if this equals 0, we can go ahead and plug all this in on one side. So let's go ahead and, since this is an addition thing, let's go ahead and break this down into factors. So x squared, if we put x plus h for x times x, we have x plus h times x plus h, and then minus 4x plus h, and then plus 7, and 7 doesn't have an x, so we're good there. Let's go ahead and off to the side do x plus h times x plus h. So x times x is x squared, x times h is xh, and h times x is xh, so let's go ahead and put 2xh, and then h times h is h squared. So here we have x squared plus 2xh plus h squared. And you know what helps me is if you choose one of your variables to go in front always. So in this case, I'm gonna always put my x's before my h's just to make it easier to visualize. So now let's distribute this one here. So now we have minus 4x minus 4h, and then a plus 7. So this whole thing is this right here. So yeah, now if we want to plug it into the equation, we just take this, let's move it over here. So we have x squared plus 2xh plus h squared minus 4x minus 4h plus 7, and then we're going to subtract. So this minus, and then the regular equation. So minus x squared plus 4x, because it was a minus 4x up here, and then plus 7. And then we can go ahead and, well, we should have been able to cancel that, so I don't understand what's happening here now. Why is this a plus 7? This doesn't seem right. I think we mixed up our signs up here somewhere, so just hang on a second. minus 4. Oh, so this should have been a minus 7, which would make this a minus 7 and this a minus 7. So this should be plus 7. And then we cancel this out. So we have a minus x squared, and an x squared cancels out, and a minus 4x, and a 4x, and a minus 7, and a 7. All of this should cancel out. And then we're left with 2xh plus h squared minus 4h. And then remember, we did not divide by the h. Always divide by the h. Do not forget to divide by the h. So divide by h, and that gets us 2x, because this h cancels out, plus h, because we have two h's, minus 1h. So now there's one more h, and then minus 4. So this right here is our answer for this example. Now I'm wondering if we should just go ahead and do as much as we can in one go. I think we can do that. So let's go ahead and do one more. Flip the page over. Okay, so let's rewrite the template formula, which is what I'm going to call it now, I guess. So we have f of x plus h minus f of x over h, where h cannot equal 0. I don't think you'll have to worry about this part of the rule at all. H shouldn't ever be set equal to 0 in any of your equations. Alright, so for this example, we're going to use x to the third plus 3x as our equation. This is a given equation. So for starters, let's find f of x plus h and insert x plus h into all these. So we need 3x plus h's for this one, plus 3 times x plus h. Don't forget about the 3 times the x plus h, but this part here is going to give us a little bit of trouble. So let's just start with x plus h, which we know is x squared plus 2xh plus h squared, and now we have to multiply that by x plus h. So x squared times x equals x to the third. X squared times h equals x squared h. 2x h times x equals 2x squared h. And 2xh times h equals 2xh squared. And then plus x h squared plus h to the third. And then if I believe we can combine like terms here. So there's only one x to the third, but then we have x squared h and 2x squared h, so plus 3x squared h right there, and then we have 2xh squared and xh squared here, so plus 3xh squared, and then plus an h to the third. So then we have that, and now let's remember this part up here, so we distribute plus 3x plus 3h. So now we've got this big guy here, and I'm going to go ahead and rewrite it so that we have some more room. So x to the third plus 3x squared h plus 3xh squared plus h to the third plus 3x plus 3h h, and then we're going to subtract just f of x, which was our equation up here. So minus x to the third minus 3x. So the minus 3x can cancel with this 3x here, and the minus x to the third can cancel with this positive x to the third over here. So we're left with 3x squared x, or 3x squared h plus 3hx squared plus h to the third plus 3h. And then don't forget the minus, or the divided by h. So then you just take an h out of each of the terms. So we have 3x squared plus 3xh plus h squared plus 3. 3xh, 3, yep, that is correct. So that is our answer. I really hope that was helpful. Thank you for watching.